All right, here is the worked out problem set 8-6, 7, 9, 11, 12, and 17. So for 8-6, we have this generic rectangle. We need to find the dimensions. Since this is an x squared, I know there's going to need to be an x and an x. A 2 couldn't go here because that's a -3, so I'm going to put the 2 on the other side, which means this would just be a 1, which would mean this would be a -3. And then I'll check and make sure that works. -3 by a -6y. That would give me a 2y. And does that work here? Yes, it does. And -3 would have to be by a -4, which also works the other way. So that means that this would be 2x minus 3 times x plus 2y minus 4. Those are my dimensions. And then the inside terms, once I simplify them, would be 2x squared plus 4xy, and then minus 11x, because 3x and 8x is 11x, minus 6y plus 12. All right, for 8-7, we're multiplying using a generic rectangle. So I've got 4x minus 1 and 3x plus 5. So that would give me 12x squared minus 3x, 20x, and -5. I combine my like terms, 12x squared plus 17x minus 5. For part B, I need to remember that this is the same as 2x minus 7 times 2x minus 7. But once again, I do that with a generic rectangle. So 4x squared minus 14x minus 14x plus 49 gives me 4x squared minus 28x plus 49. Okay, in 8-9, we are doing diamond problems. So for A, we need two numbers that multiply to -80, but add to 2. So I'm making my little list of factor pairs here. 40 and 2, those are too far apart to come to a 2. 20 and 4, too far apart. 10 and 8, that'll work. One of them needs to be negative, but the sum needs to be positive. So -8, +10. 12 and -7, that would be -3 and -4, because they add to -7 but multiply to 12. Numbers that multiply to 0, that would be 0 and 7, add to 0. -81, that would be -9 and +9, they add to 0. 6x squared, that would be 3x and 2x, add to 5x. And -7x, that would be 7x and -7x and +1x would add to -6 but multiply to -7. For 8-11, we are graphing a parabola on paper. In this unit, we're going to learn some shortcuts for this, but for right now, I'm just making sure that we understand how to do it the long way by making the table and working it out. Okay, so nothing about this rule makes me think this is going to be anything weird, so I'm just going to go from -3 up to +3. And so then I'm going to evaluate my rule for each term, or for each input. So y equals -3 squared minus 2 times -3 minus 8. So that would be 9 plus 6 minus 8. So that would be 7. And then I'm going to keep going like that. So -2 squared would be 6. -2 times -2 would be +4. Minus 8, so that would be 2. -1. That would not be a 6. -2 squared would be a 4. 4 plus 4 minus 8 would be 0. So when it's -2, 1 should equal 0. When y is negative, or when x is negative 1, that would be negative 1 squared is 1. And then negative 1 times negative 2 would be plus 2 minus 8, that would be negative 5. When x is 0, my y-intercept is negative 8. When x is 1, that's 1 squared minus 2 minus 8. So that would be minus 9. And then 2 squared minus 4 minus 8 would be negative 8. Looks like I found my vertex. And then this one, according to the pattern, should be negative 5, but we should double check to make sure. So 9 minus 6 minus 8. So that would be 3 minus 8, that would be negative 5. Fantastic. Okay, so now I have my points. I'm going to graph it in a table, or I'm going to graph it in a graph. And looking at my numbers, it looks like I do kind of need a big range for my y. So I'm probably going to count by 2's on my y-axis, but by 1's on my x. So now I'm going to plot my points. So at negative 3, I should be up at 7. At negative 2, I should be at 0. Negative 1 should be down at negative 5. 0 is at negative 8. 1 is at negative 9. 2 is at negative 8. 3, oops. 1 is at negative 9. 2 is at negative 8. 3 is at negative 5. And because this is a parabola, I know it's going to continue up the same way the other side. So like if 3 was at negative 5, then 4 is going to be at 0, because that's the next point over. And 5 is going to be up at 7, like that. And I can connect my point. Like that. They wanted you to articulate that the y-intercept is the p-value. So y-intercept is 0, negative 8, which is also y equals x squared minus 2x minus 8. Those are the same thing. Okay? And then they also wanted you to name the x-intercepts, which for this one were negative 2, 0, and 4, 0, are your x-intercepts. And the lowest point of the graph was 1, negative 9. Okay, on 8-12, we're just evaluating some expressions with square roots in them. This is going to lead to something later on in this chapter. So there's a reason why we're doing this. So 5 times the square root of 36, that's the same as 5 times 6, which gives me negative 1. For B, I had 1 plus the square root of 39. I need a calculator to do that, so I'm going to say the square root of 39 is about 6.24. So I'm going to do 1 plus 6.24, which gives me 7.24. Could have done more or less decimals from that. Just make sure you round appropriately. And to C, negative 2 minus the square root of 5. So we're going to do, I'm just going to do it on a calculator, negative 2 minus the square root of 5. When I type it in, it looks like that. Hit enter, and it gives me negative 4.23. No, 0.24. Negative 4.24 if I round accurately. That's obviously just an approximate answer. So those are irrational, but these are the decimal approximations of those. All right, and finally, HF17, we get to do some factoring. We've waited so long. So for A, we have x squared minus 4x minus 12. So we're going to do a box and a diamond, x squared minus 12. I'm going to multiply them to get negative 12x squared and a minus 4x on the bottom from right there. So I need two numbers that multiply to negative 12x but add to negative 4. I think that's going to be a 6 and a 2. Those are going to have a difference of 4. So negative 6x and positive 2x. Put those in. And this looks like it'll be a 6 and a 2. This will be a minus. Like that. This equals x plus 2 times x minus 6. For B, we have 4x squared plus 4x plus 1. Another rectangle and a diamond, so 4x squared and 1. And that'll be a 4x from there. So two numbers that multiply to 4x squared and add to 4x would be 2x and 2x. 2x and 2x. So that gives me 2x plus 1 and 2x plus 1. So 2x plus 1 times 2x plus 1. Oops. Didn't really do that. Sorry. Alright, for C, we have 2x squared minus 9x minus 5. I start with my A and my C. And multiply to get negative 10x squared and negative 9x. So that would be negative 10x and a 1x. And so that would give me a 2x and an x. That would give me a 1 and a minus 5. 2x plus 1 times x minus 5. Alright, and the last one, we have 3x squared plus 10x minus 8. I sharpened my pencil. It's working better now. So I have 3x squared minus 8. That gives me a negative 24x squared and a positive 10x. I need two numbers that multiply to negative 24 but add to 10. I got a little stuck on this one. I need to do 24 and 1. 12 and 2. That'll do it. So I need a positive 12x and a negative 2x. So 12x and 2x. So this side must be the 3x. This side must just be an x. That must be a 2 and a 4. Maybe some negatives in there. Oh, I forgot to write my negative from the 2. There we go. So that's a negative 2. There we go. Okay, so that gives me 3x minus 2 times x plus